Right, today's lesson is section 2.7, the first day where we are talking about inverse functions. So first we have our formal definition for inverse functions. And it says, let f and g be two functions such that f of g of x is equal to x and g of f of x is equal to x. We do need to say that this is for every x in the domain of G, and then for the bottom function, the g of f of x, it's for every x in the domain of f. Okay? And it says under these conditions, so meaning if we do both composite functions and they both equal x, then we know function g is the inverse function of function f. So it says g, instead of writing g, we now write it in inverse notation, which is f to the little -1. Okay, you might remember that from Algebra 2, because you guys did find inverse functions of, I think you pretty much did basic linear, maybe you did some quadratic. So what that means is that if we rewrite this, instead of being f of g of x, it's now f of f inverse of x. And instead of being g of f of x, it is now f inverse of f of x equals x. Okay, so with all of that being said, what we are going to do today is to show that f and g are inverses of each other, we need to show, and I'll write it in our normal notation, that f of g of x is equal to x, and that g of f of x is equal to x. So two things. So we are trying to find two composite functions today. Now let's just remind you, even way back when in Algebra 1, where we found inverses of normal or ordered pairs. So it says to find the inverse of ordered pairs, you simply switch the x and the y coordinates. Okay, so if I were to look at these ordered pairs, the inverse would be 5, 1, 4, 2, 6, 3, and 8, 4. Okay, that's the inverse. All right, so for our work today, it's to show that the following functions are inverses of each other. So they're pretty much saying they are, we just have to show it. So first of all, we have to find f of g of x. So that means I'm going to write my f function down, but I know myself, so I'm going to leave a big space for the x, because I know that I will probably forget that -1. So I wrote my f function down, and now where I left my big blank space, I'm going to write my g function. So it's the cubed root of x plus 1 all over 2. And now we just have to simplify this. So I'm looking and saying, okay, I have the cubed root. Oh, but that whole function is cubed, so my cubed and cube root cancel each other out. I don't think that's the color I had. Here we go. So now I have 2 times the quantity x plus 1 all over 2 minus 1. And then I look and say, hey, my 2's now cancel. I'm left with x plus 1 minus 1, plus 1 minus 1 cancels. We are just left with x. So that one worked out pretty nicely. Now we have to do, and I need to see both of them. Now I have to do g of f of x. Because remember, just getting one of them to equal x is not enough. They both have to equal x. So I'm going to take my g function. I'm going to leave a big blank space where my x is and write the rest of my function down so I don't forget any piece of it. And my x function is now 2x cubed minus 1. All right, so looking at this, my cubed and cubed root can't cancel each other out. So let's see what else I can do. Well, if I look inside of here, I don't really need those parentheses. So -1 plus 1, they cancel. So now let's rewrite this. I still have my cubed root, don't forget that, 2x cubed over 2. Well, now my 2's cancel. I have the cubed root of x cubed My cubed and cubed root cancels, and we are just left with x. So therefore, we showed that they were inverses. So I'm just going to write yes, inverses. All right, so that's the first step. All right. I will tell you, for this your turn, it's going to be a lot of work. This will probably be the longest problem that you do, and it is going to require you to remember what we did with complex fractions. Okay, so that's I'll get you started, but I'm not going to show you guys how to solve this. For some reason it did not want to do my G. So I'll just start setting this one up. So here's my f function is x plus 3 divided by x minus 2. So my g function goes in here, so 2x plus 3 all over x minus 1. So my hint to you is to rewrite your division horizontally. Find a common denominator here, common denominator here. Once you get one fraction divided by one fraction, you keep switch flip. Okay? So it's going to be a lot of work for both of them because this is only f of g of x. Then you have to do the same thing for g of f of x. Okay? You do get this one. Oh, my screen moved. You do get that one to equal x, and this one over here does equal x. Okay? So that's your goal. All right, second and last example. It says which of the functions, should say functions, is the inverse of f of x. So this is now saying, okay, now you have three functions. Figure out which of these two, g or h, is the inverse of f of x. So that means this is like two problems that we just did. So we have to find f of g of x, and then we have to do g of f of x. Then we're going to have to do f of h of x and h of g of x. Because they could both be inverses, neither of them could be inverses, so let's go ahead and get started. All right, so if I'm doing f of g of x. All right, so I was looking at my h function. So my f function is just 5 in the numerator divided by my x minus 2. My g function is x minus 2 over 5. So now you're going to write this as two fractions horizontally. So 5 divided by x minus 2 over 5 minus 2 over 1. So this is your little bit of a reminder on complex fractions. Common denominator is 5, so I have x minus 2 minus 10. So 5 over 1 divided by x minus 12 over 5. Keep the first fraction the same, multiply by the reciprocal. Multiply straight across. All right, now I'm looking at this and thinking I cannot do anything else that does not equal x, so those guys are not inverses. So that means I don't even need to do this. Done with the first part. All right, so now let's take a look at this. So if this one doesn't work out, we could pretty much say it's neither. So now I have to take my f function again. So that's 5 over a big x minus 2. I have to substitute my h function in, which is 5 over x plus 2. All right, so my minus 2 plus 2, they cancel. I see that right away. It just helps me a little bit. So 5 over 1 divided by 5 over x. Now I have one fraction equal to one fraction. I keep the first the same, multiply by the reciprocal. My 5's cancel. We are just left with x. That's awesome. But now what about h of g of x? Still have to do this one because it might not work out. So my h function is 5 all over x plus 2. This is 5 over x minus 2. So I end up having 5 over 1 divided by 5 over x minus 2. So I keep the first, switch, flip. Why that's being weird today. My 5's are going to cancel, so I'm left with x minus 2 over 1, which is just x minus 2 plus 2. They cancel. We are left with x. Put a little check mark there, and then we can say, hey, those two worked out. So f of x and h of x are inverses. Okay. All right, so that's your whole lesson today, just determining if functions are inverses.